In a daring announcement, scientists claim to have discovered a new planet unlike anything known. This planet is fascinating not only because of its size and location, but also because it emits light that appears to be artificial, according to NASA, which is known for its groundbreaking discoveries. Are we on the verge of discovering information that could fundamentally alter our perspective on the cosmos? Could this suggest that other planets may have life as well? We will soon discover the truth about these extraordinary lights by investigating NASA's amazing discoveries. The Dawn spacecraft was launched in 2007 by NASA with the goal of examining some of the most intriguing objects in our solar system. Dawn was able to set out on a journey thanks to its 3 ion engines, which started with a 14-month investigation of Vesta, the second-largest asteroid in the belt. Dawn sent back precise pictures and information that showed Vesta's complicated surface and its varied geological history. Dawn then began the second, and possibly most exciting, phase of its journey, a comprehensive investigation of the dwarf planet Ceres. Dawn was able to leave Vesta's orbit and head toward Ceres thanks to its ion engines, something that would have been impossible with conventional chemical propulsion. These engines provided a gentle thrust that allowed Dawn to travel a great distance and enter a stable orbit around Ceres. The largest object in the asteroid belt between Mars and Jupiter, Ceres was discovered in 1801 by the Italian astronomer Giuseppe Piazzi. Prior to its reclassification in 2006, it was regarded as the smallest dwarf planet in our solar system for a considerable amount of time. Ceres is the largest and most massive body in the asteroid belt and one of the most fascinating due to its distinctive characteristics. Its diameter is approximately 950 kilometers. The first detailed images of this mysterious world, which showed bright spots all over its surface, especially in a large crater known as Ocata, were eagerly anticipated by scientists. These bright spots sparked immediate interest and speculation in the scientific community. A hazy, low-resolution Hubble Space Telescope image was the best we had of Ceres before dawn. The prospect of finally getting a close-up view of this dwarf planet promised great discoveries because very little was known about it. The Dawn mission sought to improve our understanding of the formation of the solar system and the role of water in the formation of planetary bodies. The highly reflective material, possibly salts left behind by sublimated water, that is responsible for the bright spots on Ceres and other asteroids could be what's behind them. The discovery suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt liquid water or brine instead of molten rock. But what exactly are these mysterious lights? And what do they reveal about Ceres' nature? Could they be a sign of something more extraordinary or of ongoing geological activity? Ceres stands out from other bodies in the asteroid belt because of its size, mass, composition, and potential to contain water and ice. Unlike typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could reveal more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking an important milestone as it prepared to provide the first close-up views of the largest object in the asteroid belt. As Dawn drew closer, images of Ceres became increasingly detailed, revealing a world previously shrouded in mystery. The first images showed a cratered surface indicative of a long history of impacts. Scientists and space enthusiasts were intrigued by the mysterious bright spots in the gloomy, rocky terrain. As the resolution of the images increased, the scientific community formulated theories about the nature of these bright spots. Could they have been something even more exotic, or were they simply ice patches that caught the sun's rays? Speculations ranged from mineral deposits to potential signs of cryovolcanic activity. A closer look revealed, to everyone's surprise, that the brightest spot was not a single spot but rather a group of several distinct spots. The most widely accepted hypothesis was that these were deposits of salt left by the sublimation of water. This suggested that Ceres had, or still has, some form of geological activity capable of bringing water or brine to the surface, where they quickly evaporate, leaving bright, reflective residues. These findings challenged existing notions about Ceres, painting a picture of a more dynamic and complex world than had been imagined. The possibility of the existence of groundwater or brine pockets could have profound implications for our understanding of the potential for life in our solar system. Ceres is an intriguing dwarf planet, often described as an icy world with a rocky but porous surface. It is notable for its unique composition, which sets it apart from the majority of asteroids, which are mostly made of rocks and metals. Its surface is a mixture of water, ice and hydrated minerals, including clays and carbonates, which give it a less dense structure than its rocky neighbors. According to this composition, Ceres contains a significant amount of water. Its surface layer is rocky but porous, with ice and other volatiles trapped, making it more like a comet than a typical asteroid. The dwarf planet is believed to have a distinct interior composed of a muddy mantle and a core rich in water ice, which accounts for approximately 50% of Ceres' total volume. Ceres' mantle is probably a mixture of rock and brine, surrounding a core possibly composed of denser materials such as silicates. The presence of a significant amount of water ice suggests that Ceres may have hosted liquid water in the past, especially if its core was heated by radioactive decay early in its history. This internal structure distinguishes Ceres from its neighboring asteroids and raises intriguing questions about its potential for geological activity and the role of water in its evolution. But that's not all. Ammonia clays were discovered. The discovery of ammonia-bearing clays on Ceres was unexpected and particularly intriguing. Ammonia is not stable in the inner solar system over long periods of time, which suggests that either Ceres formed farther out, perhaps beyond Jupiter's orbit, and migrated inward, or that material from the outer solar system was somehow delivered to it. This raises compelling questions about the movement of bodies and materials in the early solar system. If Ceres did indeed originate in the colder, outer regions and later settled into its current position within the asteroid belt, it could serve as a time capsule containing pristine materials from the solar system's infancy. Furthermore, the presence of ammonia compounds and water ice increases the potential for habitability. While no direct signs of life have been discovered, the combination of heat, water, and chemicals like ammonia provides the essential ingredients for life as we understand it. It also opens the door to further exploration, not just of Ceres, but of similar icy bodies in the outer solar system such as Europa, Enceladus, and Titan. As Dawn continued to orbit and study Ceres, more findings emerged. The spacecraft detected organic molecules, carbon-based compounds that are the building blocks of life. These were found near Ernutet crater, and although their origin remains uncertain, their existence supports the idea that Ceres may have once harbored conditions suitable for prebiotic chemistry. Ceres, once considered just a rock in the asteroid belt, has become one of the most exciting and mysterious objects in our solar system. It has reshaped how scientists view small planetary bodies. Far from being inert and lifeless, Ceres reveals a dynamic world with the potential for water, organic chemistry, and even geological activity. NASA's Dawn mission officially ended in late 2018 when the spacecraft ran out of fuel and ceased communications. However, its legacy lives on. The data it collected continues to be studied and analyzed, shedding new light on the processes that shaped our solar system. The story of Ceres is not over. With growing interest in returning to the outer solar system and investigating its icy moons and dwarf planets, future missions may revisit this enigmatic world. Robotic landers or even sample return missions could one day confirm the presence of subsurface oceans or provide deeper insight into the chemistry that occurs beneath Ceres' surface. In the broader context, discoveries like these push humanity closer to answering one of its most profound questions: are we alone in the universe? Ceres may not provide the final answer, but it certainly adds a crucial piece to the puzzle. One theory suggests that this dwarf planet may have formed in a cooler part of the solar system and then migrated inward. The presence of ammonia may lower the freezing point of water, supporting the existence of surface brines. Not only do these insights into the history and composition of Ceres help us better understand this fascinating dwarf planet, but they also shed light on the processes that govern the formation and evolution of icy bodies all over the solar system. Cryovolcanism is a fascinating and uncommon geological process, particularly in comparison to the more common volcanic eruptions that occur on Earth. Cryovolcanoes, also known as ice volcanoes, expel materials like water, ammonia, or methane, in contrast to traditional volcanoes, which erupt molten rock. Cryovolcanoes on Ceres are extremely cold environments in which these substances can exist as liquids or gases. By allowing water laden with dissolved salt to reach the surface, cryovolcanoes on Ceres function. The salt water rapidly changes from a solid or liquid state to a gas when it comes into contact with the vacuum of space. This leaves behind glowing, reflective deposits of salt. These salt residues form the mysterious bright spots observed on the surface of Ceres. In a crater known as Ocata, the most well-known of these bright spots is located. Due to its high reflectivity and periodic hazes observed by the Dawn spacecraft, this region has received a lot of attention. Water sublimation is thought to be the cause of these hazes, which suggests that cryovolcanic activity may still be taking place, or has taken place only recently, on Ceres. In addition to Ocata, Ceres hosts several other bright spots, each with its own unique characteristics. Cryovolcanism may be a widespread phenomenon on Ceres because these spots are dispersed across the dwarf planet's surface rather than confined to a single location. These bright spots challenge previous notions that Ceres is a geologically inactive world by highlighting its dynamic and active nature. The surface of Ceres is dotted with a variety of craters, each of which tells the story of the dwarf planet's history. As more detailed images were taken by the Dawn spacecraft, scientists gained even deeper insights into Ceres's surface and internal processes. One of the most exciting revelations was the presence of organic molecules, the building blocks of life. In 2017, NASA announced the detection of aliphatic organic compounds in the region around the crater. These complex, carbon-based molecules are commonly associated with biological processes, although they can also form through abiotic mechanisms. The presence of organics, coupled with brine deposits and evidence of past or present liquid water, suggests that Ceres may once have had, or still maintains, the conditions necessary to support microbial life. While no life has been detected, the convergence of organic chemistry, water, and internal heat makes Ceres a compelling target for astrobiological research. Ceres also holds a special place in astronomical history from a cultural and historical perspective. It was the first object discovered in the asteroid belt and was initially classified as a planet before being redefined as an asteroid and later as a dwarf planet. Its changing status mirrors the evolution of astronomical classification systems and our growing understanding of celestial bodies. From a scientific perspective, Ceres represents a time capsule from the early solar system. Unlike larger planets that have undergone extensive geological processing, Ceres has remained relatively unchanged. It provides a window into the conditions that existed more than 4.5 billion years ago and aids in the development of theories regarding the migration, differentiation, and formation of planets. Please share your thoughts with me in the comment section. If you liked the video, remember to like and subscribe. Future missions to Ceres could provide even more insights into its complex geology, chemistry, and potential habitability. Robotic landers or orbiters equipped with advanced instruments could analyze surface and subsurface materials in greater detail, especially in regions showing signs of recent activity. A sample return mission would be particularly valuable, allowing scientists to study Ceres's materials in Earth-based laboratories, potentially uncovering biosignatures or other critical clues about the planet's history. The interest in Ceres is not just scientific, it also has implications for the future of space exploration and resource utilization. The presence of water ice, salts, and other volatiles makes Ceres a candidate for future in-situ resource utilization, ISIU, which could support long-term human missions in deep space. If we ever establish a human presence beyond Mars, Ceres could serve as a vital waypoint or supply depot. Moreover, studying Ceres in the broader context of dwarf planets, alongside Pluto, Eris, Haumea, and Makemake, allows scientists to develop a more comprehensive understanding of how these bodies fit into the structure and evolution of our solar system. Each of these objects tells a different story, and together they reveal the diverse pathways planetary bodies can take. As technology continues to advance, and as humanity's reach into space expands, dwarf planets like Ceres will remain critical to answering some of the most profound questions we have. How common are the ingredients for life in the universe? What roles do small planetary bodies play in shaping planetary systems? And how can we use our knowledge of these worlds to guide our own journey beyond Earth? Stay curious, stay inspired, and as always, thank you for exploring with us.